Hello and welcome to T2 Day 19 of Honors Precalculus. Today we're going to continue talking about vectors. First, you have the idea of a direction angle, and this is the angle a vector makes with the positive x-axis, which would be right here in this diagram. And as you remember from yesterday, you can write a vector in component form, and that would be the horizontal for the first part, and then the vertical right here, this blue part, as the second component right there. You should also remember that sine of an angle is equal to the opposite side over the hypotenuse. So in this triangle right here, the hypotenuse, the magnitude of v is the hypotenuse. So in this case, the sine of theta is equal to the opposite side over the hypotenuse, which is v. So that means that the opposite side length is the magnitude v times sine of theta. That's where this comes from. And you can do similar work to get this. So if you have this angle theta and you have the magnitude of the vector here, you can find the horizontal and vertical component. So we have this vector and it says find the components of vector v, and it tells you the direction angle is 115. So our formula says that this is just going to be the magnitude of v times cosine of theta, comma, the magnitude of v times sine of theta. And now we can plug everything in, because the magnitude here, it tells us, is 6. So it's 6 times cosine of 115 degrees, and it's going to be 6 times sine of 115 degrees. Now you can use a calculator here because it's not the best decimals to work with from your head. It's going to be negative 2.536, comma, 5.438. Where do those numbers occur? That number right there, this number right here is this distance. It should be negative because it goes backwards. And then this number right here is this. It goes up right there. That's where they are. So if you have this angle and the magnitude of v, you can find the components rather quickly. So in these two questions, it says find the magnitude and direction of each of the following. And direction means direction angle. Direction angle. So for this one right here, what's the magnitude of u here? Well, that's just going to be the square root of negative 3 squared plus 4 squared. So that's just going to be the square root of 25, which is 5. So that's the magnitude there. So now if we want to find both components of this, we literally just need to use the formula. So what do? Well, excuse me, we already have the components. We need the angle. We need the angle right here. So what do we know? Well, we know that the vector u, one way to write it, we have is the magnitude of v cosine theta, comma, the magnitude of, it's u, in both cases, sine of theta. We know that's the case. Well, we know that the magnitude is 5, so we can plug that in right there. So we know that u is going to be 5 cosine theta, comma, negative 3, not negative 3, it's going to be 5 sine of theta, like this. Well, we know that negative 3 is the x component, so this right here has to be negative 3. Those two things have to be the same. This and this have to be the same. So 5 cosine theta is equal to negative 3. So cosine theta is equal to negative 3 over 5. So theta, when you do this, is going to be cosine inverse of negative 3 over 5. Now that's something you need your calculator for, and you'll get 126.870 degrees. Similarly, you can do this other question over here. Very, very similarly. You can find the magnitude of v, which is going to be the square root of negative 5 squared plus negative 12 squared. And when you do that out, you end up with the square root of 169, which is 13. But you also know that you could write what we did before, but here's another method. So this is a different method here. If you draw this vector, you know it goes down, back 5, and down 12, like this. And you're trying to find the directional angle. So if you go back 5 and down 12, you could try to find this angle right here, if you wanted to. And that angle is going to be the tangent of that angle is going to be negative 12 over negative 5. So this is another way. You could do it the other method, but this is just a second way. So theta is equal to tan inverse of negative 12 over negative 5, and you end up with 67.38 degrees. Now this isn't the directional angle, it's this angle. The directional angle you want is from the positive x-axis, you want this. So what you need to do is you need to do 180 plus 67.380, which is going to be 247.380. This is just another way to do the same thing. So now let's talk about the idea of a bearing. The bearing of an object, also called the compass heading, is sometimes given as the angle of the line of travel measured clockwise from due north. So what that means, if this is due north, which it is, it's the angle that the vector makes. Let's say the direction was this. This is the bearing angle right there. That's the bearing angle. Angle clockwise from due north. So I could ask this question. A plane is flying on a bearing of 65 degrees at 500 miles an hour. So due north is this direction. 65 degrees from there is about, let's say, this angle right here. But we're going to label it. That means that this angle right here is 65 degrees. And we'll call this the plane vector. We know that the plane vector's magnitude is 500 miles per hour. Now it asks find the component form of the velocity of the airplane. That's asking us for what is this and this length, because that's how we can write the vector p. We want to find, we know vector p is equal to sum a and b, or another way you could say that if you want to is sum x and y, the x component and the y component. Now what we know from our formula is that it's going to be the magnitude of the vector 500 times cosine of the angle that it makes with the positive x-axis. So we need this one, this angle alpha. Well, we know 65 plus alpha is 90, so alpha is going to be 25 degrees. This is 25 degrees. So that 25 degrees goes there, and then you have 500 sine of, again, 25 degrees right there. Now, that's not a nice, quote, nice trig, something from the unit circle. So this tells us that the vector is going to be 453.134, comma, 211.309. Now, those are numbers you would get using your calculator, plugging these in, making sure you're in degree mode. So this is adding in another layer, which is the idea that a plane could be flying, but there could be wind blowing it. This is kind of like current in a river. So the plane is going to leave the airport, and there's a 65-mile-an-hour wind with a bearing of 60 degrees. So the plane leaves the airport, and there's a wind at 60 degrees. So the wind, if this, remember, this is north. We'll put that there. We'll call this the wind vector right here. Here's the wind vector right there. And what we know is that this angle right there is 65 degrees. And we know that the magnitude of W is 65. That's the wind vector right there. Oh, sorry, not 65, 60 degrees. It's 60 degrees, and it's going 65 miles an hour. Find the compass heading the plane should follow and the ground speed of the plane if the plane wants to go directly east. So the plane wants to go here. It wants to go, this is where it wants to go, right there. So the way you can think about this, if the plane just goes in that direction, it's going to get blown this way. It's going to get blown that way. So it's going to end up going like this. It's going to go too far to the north. So because of this wind right here, because of this wind, it has to go not due east if it wants to end up going due east. So you can think of this as where do you want the plane to head? So what you can do is, let's instead call this the resultant vector. And this is what the plane tries to go. And the plane is going to head in some direction like this. But because of the wind is going to blow it up, and it's going to end up going to the east. Well, the wind vector, we know, is going to be 65, which is the magnitude cosine of this angle right here, which is 30 degrees. And then 65, not comma, 65 sine of 30 degrees. So that's what the components are for the wind. The plane, we don't know what this angle is right here. We'll call this theta right here. The plane, like where it's going to push it's going to go in that direction, but it's going to get blown to a easterly direction. We don't know what that is, but we know that it's going to have is 450 miles an hour if there was no wind. So that's the magnitude of just this vector right here. So it's 450, but we don't know what that angle is. So it's going to be 450 cosine theta, like that, or sorry, sine on this other side. Now, we have another one, which is the resultant vector. The resultant vector is going to be, is going to be this vector plus this vector. You add the two together. And the key thing is that if you add these first two things together, so it's going to be this and this, you end up with 65 cosine 30 degrees plus 450 cosine theta right there. And you know it, since it's going straight east, east means it's not going up or down, like it's not going this or this, so it's going to be comma 0. So what this means is we have enough information here to set up an equation. We know that this part plus this, when you add them together, has to be 0 because they're going to cancel each other out and leave you with just going to the east. So the simultaneous equation you can set up is 65 sine of 30 degrees plus 450 sine of theta will equal 0. We know that because it's going east, which means it has no y component. The y component is 0. So this question is not asking about the horizontal component, just right now this allows us to find the theta value, which is what we need. So when you do this out, you can do this on your calculator, but you don't really need to because you know sine of 30. So this comes out to 32.5 plus 450 sine of theta equals 0. And you keep on cruising through this, and you'll end up with sine of theta is equal to negative 32.5 over 450. You need a calculator to do this, so theta is going to equal sine inverse of negative 32.5 over 450. And yes, you use your calculator and you end up with negative 4.142 degrees. So that means this angle right there is negative 4.142 degrees. So the plane should point itself a little bit not to the east, a little bit below east, because the wind is going to push it up to go directly east. Now, so what's going on here is the plane is trying to do this, but it's being blown to here all the way to the east. So this is the resultant vector, which is longer than the plane's initial if it had no wind path. So the new resultant speed needs to be found from the vector, which we don't have yet, but we will. What we do know, though, is that the angle is this, so we can put it into this part right here. So we know that W plus P is going to equal, you plug into this right there, negative 142. So you plug it in right there, and you end up with, when you do this out on your calculator, 505.117, because it's going east at 0. So what that means is the magnitude of this vector, you can square it and take the square root, but it's just going to be 505.117, which makes logical sense because it should be, or I think it's kilometers an hour, is it? It's miles per hour, yeah, miles per hour, which should be a little bit more because, again, the plane with no wind would be going there, but the wind is pushing it up to the east, so it pushes it forward a little bit. So the plane starts going 450, but with the wind not directly behind it, but partially behind it, it ends up going 505.117 miles per hour. So just remember the key things here, east. The key thing here, east, means that this has to be 0, which allows us to set up this equation and then solve for the angle measure, which is right here, the theta. And then that allows us to get the x component right there, which allows us to get the resultant actual path of the plane.